Hey, hello and welcome to today's GFG problem of the day. Hope you are doing well. So let's say today's problem, peak element. Okay, so we'll be given an array. Okay, let's say the array is this, right? So what we want to do is we want to return the position of the peak element. Okay, now what is a peak element? A peak element is an element whose value is greater than the values of the adjacent side of the adjacent values. Okay, so here in this case, right, 4 is greater than 3, right, on the left hand side, and 4 and 3 on the right hand side as well. Okay, so if such is the case, so this is a peak element. Okay, so generally what they are saying is it will be something like this. So here there'll be a peak element, and the values on the left hand side they'll be sorted in ascending order, and the values on the right hand side it will be sorted in descending order. Okay. So if such is the case, there's an element whose value is greater than the adjacent values, then this is a peak element. Okay. So there are a few cases. The other case can be like this as well. There is a plateau, right? So here, for example, here it is 5, right? Here it is 5, here it is 5, right? Here it is 4, and here it is 4. So this would be the peak element, right? So if so, why it is a peak element? Because its value is equal to as well, right? Greater than equal to, they have said. Greater than equal to, they've asked, right? So this will be the peak element. Its value is greater than equal to, right? 5 on either side. So this will be the peak element. So other case would be this, right? So this is the array given, right? So in this case, this will be the peak element, right? There are no elements post this, right? This is the last element, right? So this will be the peak element. Other case can be like this, sorted in descending order, right? So this will be the peak element. The zeroth position will be the peak element. Okay. Okay. Now how to solve this problem? So one easy approach would be to traverse the array, right? To traverse the array and find such element whose value will be greater than equal to the values on the either side. Okay. If this is the case, return the peak element. So in this case, but the time complexity will be order of n. Now the asked time complexity is order of log n. So how to solve this problem, right? So if you see here, so there's a property, right, in the array. We see here it is sorted in ascending order before the peak element, and post that it will be sorted in descending order. Okay. So here we can leverage the property of binary search. Okay. Here we can leverage the property of binary search. So what we'll do is we will start with, right, whatever is array, we'll start with L and R, right? R, right? And wherever we find, for example, if there's a mid, right? There's a mid whose value is greater than, right? Whose value is greater than. For example, if it is greater, right? If it is greater, then the either side, right? Then this is the peak element you want to return. So let's code. Okay, let's code and you'll understand better. Okay. Before that, I'll request you to subscribe to my channel. Okay. So let's start now. So for example, first case is if the size of the array is 1 or 0, right? If it is 1, then we have to return the 0 because there's only one element and we'll consider that as a peak element. Okay. Let's see now the other cases. For example, if array of 0, right, is greater than array of 1. So in this case, this will be the 0th element will be the peak element. So this is a case, right? This one, right? Array of 0 is greater than array of 1. So this will be the peak element we have to return. Okay. Other case would be what? If the last element is greater than the second last element. In this case, you want to return the last element, the position of the last element, right? So here, if you see this case, right, the last element is greater than the second last element. This is a case. Okay. So if now coming to this one, right? Coming to this one and this one, right? So what we're going to do is we'll have a low variable which will start with 1 because if it would have been 0, then we would have written here itself, right? We would have written here itself, right? And let's have another high variable which will start with n minus 2. Again, if it was n minus 1, we would have written here itself, right? So that is why. And now what we'll do, the standard binary search, right? L less than equal to h. Now what we're going to do is we'll calculate mid as well. So L plus h minus L by 2. So we are seeing here, we are writing the Java code. Post that we'll see C++ code as well. It is almost same. Okay. So here, now what we'll check, if array of mid, right, is greater than equal to array of mid minus 1 and array of mid is greater than equal to array of mid plus 1, right? So if such is the case, we have found the peak element. We'll return the position. Okay. Now, if we have found this, if the condition matches, then this is a peak element, we'll return the position. Now, if this is not the case, so we'll check where is our mid, right? We'll check array of mid. If it is on this side, for example, right? This is the array. Now we are going to check if it is on this side, right? On this side. How will check? If array of mid is greater than array of mid minus 1, right? If it is greater than array of mid minus 1, that means we are on this side. Okay. Okay. For example, mid is here and mid minus 1 is here, right? So mostly the peak element is on the right hand side. So we have to move towards the right, towards the peak element, right? So mid plus 1 will do, right? Mid plus 1. Okay. Or if it is, we are on the right hand side, right? This side, right? Wherein here is a mid and mid plus 1, it is greater, right? Mid plus 1, mid is greater, right? We are on the right hand side. So we have to move towards the left hand side. right? So h equal to mid minus 1, right? So what we'll do? So if we find the peak element here, then we'll return here. Else, if we didn't find the peak element, we are going to return minus 1. Okay, so let's submit it. Let's compile this first. Yes, let's submit this. Okay, the solution is accepted. Let's quickly see the C++ code. It is almost same. Okay, here again, I've explained this, right? In the Java part, right? It's the same, right? This is same as well, completely same. The code is completely same. Okay, so thanks for watching. Please subscribe to my channel, like the video. Have a happy, healthy, and a great day. Thank you so much.